Okay, lesson 1.7. If I haven't blown your mind, I'm about to. This is the real kicker. So if you recall in the previous lesson, we did a long division problem, 276 divided by 12, and I think we got the answer 23 if I recall. 10-1 machine, totally fine. Now everything we just did was focusing on 10-1 machines, but 10-1 machines aren't special. We could actually do all this work in a 5-1 machine, or a 7-1 machine, or a 2-1 machine. In fact, in this lesson, I'm going to do it in a machine, but I'm not going to tell you what machine it is. I have a number in my mind. It might be a 10-1 machine, or it might be a 5-1. I'm just not going to tell you which machine we're in. In fact, just to be really, really mysterious, since people seem to like the number X when they don't know what number they're talking about, I'm going to call it an X1 machine. But I just refuse to tell you what X actually is. I have it in my head. I might be thinking X equals 10 or X equals 7. I'm just not telling you. All right, but in an X1 machine, we know that these dots always in the rightmost box are worth 1. And X dots here in an X1 machine must explode, become 1 dot here. So X of these is worth 1 of those. That would be worth X1s, that's X. X of these makes 1 of these. So XX's is 1 of these. X times X is X squared. XX's is X squared. X of these guys makes 1 of these. XX squareds is X times X squared, X cubed, and so on. So if X really is 10 in my mind, I've got the numbers 1, 10, 100, 1,000, and so on. So it's a 10-1 machine. If X is 2 in my mind, just not telling you, I'd have 1, 2, 4, 8. So this is just the general base machine. All right, so everything we've done before is fine. I can do my work just as before, and all is good. And suddenly things look grand, because I'm going to ask us right now, out of the blue, to work out 2x squared plus 7x plus 6 divided by x plus 2. I'd like to know that answer, please. I've just suddenly gone to, what is this, grade 10 algebra, polynomial division. People might complain at me, I probably should put parentheses around these things, but you know what I mean. I've got some quantity divided by, oh, do you know the name of that symbol, by the way? It has a great math name. It's called an obolus. O-B-E-L-U-S. Cool word. Divided by x plus 2. All right, we can do this. That looks horrible. It looks visually nightmarish, but let's just actually do it. 2x squared plus 7x plus 6. That's 2 of these guys, 7 of these guys, and 6 of these guys. And what we're trying to do, divide by x plus 2. What does x plus 2 look like? It looks like 1x and 2 1s. Now, we're going to be in a wonderfully deja vu-esque experience, because what we're doing is looking at patterns of 1 dot next to 2 dots in this system up here. Well, there's 1 dot next to 2 dots at the x level. But there's another one at the x level. There's one at the 1's level, another one at the 1's level, and yet another one at the 1's level. So I see 2 at the x level and 3 at the 1's level. The answer must be 2x plus 3. And in fact, if you look at this picture and compare it to the picture on the previous video, it's exactly the same work, same picture as for the 10-1 machine. All that grade 5 arithmetic of long division is really just x division as well, if you want to do a polynomial world. There it is. 2x squared plus 7x plus 6 divided by x plus 2 is 2x plus 3. I can see it, I understand it, that makes complete visual sense to me. I've got it. And by the way, if I now tell you that actually x was 10 all along in my mind, what is this number? Well, 2 times 10 squared, 200 plus 76, divided by x plus 2, 10 plus 2 would be 12, equals 2x plus 3, 2 times 10 plus 3 is 23. So actually it's back to that. But maybe x is 2, in which case I've done a different problem. I've done 2 times 4 plus 7 times 2 plus 6, whatever that number is, divided by 2 plus 2 by 4 equals to 7 or something. Anyhow, basically I've done all my grade 5 arithmetic in one hit, but I've just done it in the guise of not knowing what machine I'm in. Amazing, amazing. In fact, let's clean the board. Well, clean in inverted commas, because you can see by the smudges on my boards, I'm not very good at cleaning them in a hurry. Let's do something that's a visual, ghastly, horrible nightmare of a problem, but actually is straightforward. Let's see if we can do x to the 4th plus 2x cubed plus 4x squared plus 6x plus 3, all divided by x squared plus 3. This time I've written as a division problem like in the fraction notation. I've used the horizontal bar, which is called a vinculum, by the way. So there's the division problem. One polynomial divided by another polynomial. It's in an x1 machine. Looks horrible. In algebra classes, by the way, they tend not to teach how to divide by anything but linear denominators. Here I've got a quadratic down the bottom, so this is out of the realm of most algebra classes. Ha ha ha, but not for us, we can do it. Here goes. What does that numerator look like? How many boxes do I need? I need 3 1s, I need 6 x's, I need, 4x squareds, I need 2x cubed and just 1x to the fourth. Okay, my box is a little bit off. What's the denominator look like? X squared plus 3. Watch out, it's got a gap. It's 1x squared, no x's, and 3 1s. So I'm looking for 1 space 3 in that picture. Excuse me. Can I find it? Well, yeah. You know, I can be systematic. Maybe I'll start right here because that single dot's staring out the way. So I can see 1, no dots, and 3. You bet. There's 1 space 3. Now, I don't know what x actually is. I can't unexplode, but if I could unexplode, that'd all be sitting here. This really is that quantity at that level. All right, any more? You bet. There's 1 space 3 right there, and 1 space 3 right there. So there's 2 at the x level. Any more? You bet there are. 1 space 3 is 1 at the 1s level. In fact, that's used up all the dots, so it's actually very kind to us, but I can see right away the answer is x squared plus 2x plus 1. If you don't believe me, we could take that quantity, multiply by that one, and do the multiplication and check it really does equal that beast at the top. Astounding. Astounding. So, the text below this video on the screen has lots of good examples. It goes through setting this up slowly. You can work your way through it, have fun. You'll be amazed how suddenly easy Algebra 2 polynomial arithmetic has become in dots and boxes. I admit this is still not fun to write on paper. In fact, doing this on paper is a nightmare. But if you've got a screen with a whiteboard and want to get smudgy fingers, it's actually very fun to play with dots this way. Grand. Hours and hours of actual marvel and delight to be had here. And all is grand, except I might be pulling the wool over your eyes. So I'm going to leave off with a mystery, which will be the topic of our next lesson. So everything here looks fabulous and truly, truly spectacular. That when I do this work with people in a sort of audience situation, I get gobs of delight and relief and laughter at how just brilliantly simple this is, and everyone's in wondrous spirits until I put this problem on the board. X cubed minus 3x plus 2 equals, divided by x plus 2. What does that equal? The trouble is, I've been giving us positive coefficients all along. What do you do with a negative coefficient? So you might want to try this. Challenge number 1, how do you even represent this top line? I guess it has to involve antidots. And number 2, then what are you going to do? Look at it, play with it. And maybe this problem is actually a problem. Or there's the next lesson to look at. Right, play with this lesson first, and then mull on this guy, and then when you're ready, move on to the next lesson. Lesson was at 1.8 we're up to next. All right, got lots of good mulling. Enjoy this. Thanks.